Now, all right, 1310, probability of compound events. So we've just talked about probability of simple events. You're rolling one die or sometimes flipping a coin or things like that. This is doing a couple of things, multiple, more than one event. Okay, so when you do more than one event, it depends on how it works out. If, and you probably should write this down, if there is an and involved, you multiply. If there is an or involved, you add. So you do the individual probabilities. If they say and between them, you're going to multiply. If they say an or, you add. That means they can't really do it. You could do them at different times or whatever. So let's look at the first example. If you flipped a coin and rolled a die, okay, so on one side you're flipping a coin, on another side you're rolling a die. So they're two independent things. They want to know the probability of flipping tails and rolling a 5. So think about that coin. How many sides of the coin have tails on it? One. How many sides on the coin? Two. So the probability of flipping tails is 1/2 by itself. But we're rolling a die now. And we want the probability of rolling a 5. How many 5s are on that die? One. And how many sides on the die? 6. So now that I've got both probabilities there, I need to multiply straight across. There's nothing I can cancel out. So 1 times 1 is 1. 2 times 6 is 12. So the probability of flipping tails and rolling a 5 is 1/12. All right, now we're going to do the same thing, a coin and a die. This time we want probability of flipping heads and rolling an even number. So think about your coin. How many sides have heads? One. How many sides altogether? Two. Now, even, probability of an even. So on that die, how many sides are even? Three. And how many sides are there altogether? 6. I'm going to go ahead and reduce 3/6. What should it be really? 1/2. And now when I multiply straight across, 1 times 1 is 1 over 2 times 2 is 4. So the probability of flipping heads and rolling an even is 1/4. Okay, that is basically probability of compound events. They are doing two things. It was an and, so we multiply. Now we're going to look at things called dependent and independent, and we're going to look at a bag of marbles. Okay? Independent and dependent are very important that you understand the words with replacement and without replacement. With replacement means that you draw a marble out of the bag and you put one back in, you put it back in before you draw another, so that the bag is the same every time you draw out of it. Without replacement means marbles will not be replaced after each draw, so the bag actually changes every time you draw a marble out of it. There's actually less in there, plus less of some that you would have. Okay, so on the left side of the screen, I'm going to do problems. They're going to be identical, but the left side is with replacement and the right side is without replacement. Okay, so look at the bag of marbles. There's 5 red, 3 white, and 4 blue. I want the probability of drawing 2 red. How many marbles are in the bag all together? Lindsay? 12. There's 12. Oops, I got to change back to my pen. There's 12 marbles altogether. Okay, so we're drawing with replacement. We want a red. What's the probability we're going to get a red out of that? 5 over 12. With replacement, we put the red marble back in. The bag's exactly the same. I'm doing my second draw. I want a red again. What's the probability of that? 5 over 12. Multiply straight across. 25 out of 144. That's it. You're done. Let's do the same probability without replacement. So probability of drawing a red the very first time, so all the marbles are back in the bag, is still going to be 5 over 12. But you know what? We're going to say that first red marble that we pulled out was red. It's out of there. How many red are in the bag now for the second draw? 4. And how many marbles are in the bag now? 11. So what I'm going to do, I got 5 over 12 times 4 over 11. I'm going to cancel 4 and 12 and become 1 and 3. And it's going to be 5 over 33. 5 over 33. So see how the probabilities are different? Okay, let's try red, white, and blue with replacements. We're back on the left. Every time you put all the marbles back in the bag. So probability of getting a red, it's going to be 5 over 12 again. And we put it back in the bag. What's probability of getting a white? How many white marble are there? 3 out of 12. All right, all the marbles back in the bag. Probability of getting a blue? 4 over 12. Okay, we're going to reduce some of these before we multiply, so it's a little bit easier. So 3 over 12 becomes 1 over 4, right? And then I'm just going to cancel these two 4s and make them 1s. So when I multiply straight across, what is 5 times 1 times 1? 5. 12 times 1 times 12. So 5 out of 144. Very small chance. Same problem without replacement. So the bag is going to change every time. Probability of getting a red, well, that's the same every time, 5 over 12. I'm keeping the red marble out. What's the probability I'm going to get a white one now? 3 over 11. I'm keeping the white one out. What's the probability I'm going to get a blue one now? 4 over 10. Do you see why that changes every time?
Yeah.
So I'm going to cancel the 5 and the 10 and make it 1 and 2. I'm going to cancel the 4 and 12 and make it 1 and 3. Cancel my 3s, make them 1 and 1. Man, I just about canceled everything out, didn't I?
Yeah.
1 times 1 times 1 on the top is 1. And the bottom, 1 times 11 times 2, 22. Okay, questions about that? All right, we're not going to do any more marbles. I'm going to erase. You can go back and watch this if you didn't get that written down. We need to talk about the ors. I'm just going to do one of those. A deck of cards. Hopefully you are familiar with the deck of cards. 52 cards. There's 4 suits. 13 in each suit, 4 of each kind of card. This is with an or in the middle, okay? You add the probabilities. The probability of getting a queen of clubs or a red card. So for a queen of clubs, that's very specific. There's only one of those out of the 52. But a red card, how many of the cards are red? Half of them. So half. So in order to add 1 over 52 plus 1/2, I have to have a common denominator. What would my common denominator be? 52. So the 1/2 needs to be written. So I've got 1 over 52, 26 over 52. Does that make sense? That'd be half. And now my denominator is 52. 1 plus 26, it would be 27. So you need to find the probability of each part and then add them. These are a little bit harder because you have to have a common denominator.